This lesson is section 10.5, tangents. If you recall, a tangent is a line that touches the circle exactly once. So the first thing we're going to talk about, in a plane, a line is tangent to a circle if and only if it's perpendicular to a radius drawn to the point of tangency. So every single tangent line at the point of tangency will make a right angle with the radius. What that does for us is we can determine if a line is tangent by determining if there is in fact a right angle from the radius at that point. So in this problem, they're telling us that JL is a radius. We want to determine whether KL is tangent, and we're going to justify our answer. So we know that this side is 15, this side is 8, but this side is not 9. Only this little chunk outside is 9. I need to know what this whole thing is. What I have is a radius here and a radius here. And since all radii are always congruent, this part is 8, making this entire thing 17. Now that we have that, we can try to use the Pythagorean theorem. We'll really use its converse to tell whether or not we have in fact formed a right triangle, and that'll tell us if we have a right angle. So the hypotenuse, if there was a right angle, would be 17. So we're going to do 17 squared. You could either leave it blank or put our question mark over equals because we don't know if it equals it yet. 17 squared maybe equals 8 squared plus 15 squared. So now we're going to do some math. 289 maybe equals 64 plus 225. So we get 289, and if I add together 64 and 225, I get 289. So they are in fact equal, which means this is a right triangle, that is a right angle. So yes, it is perpendicular because we have JL is perpendicular to KL. Okay? So you go ahead, try the next one, pause, and when you're ready, check your answer. All right, so if you've done the work, we know that was 12 and 6, so this entire side was 18. We would have ended up with 324 does not equal 100. So this is not tangent. Okay? For number 5, we want to find the value of x, and it tells us that lines that appear to be tangent are. So even though they didn't draw the right angle for us here, we can add it because they told us that if it appears to be tangent, it really is. So now I have another right triangle. I have a side of x, a side of 12, and this side, if I put the x and 8 together, it is not 8x, it is x plus 8. So that would be my hypotenuse. So when I plug it into the Pythagorean theorem, I'm going to make sure I put parentheses around my x plus 8 because I'm squaring that entire thing. Right, equals x squared plus 12 squared. We have to remember x plus 8 squared is really x plus 8 times x plus 8. So x times x is x squared. X times 8 is 8x, and then 8 times x is 8x, so that's a total of 16x. And then 8 times 8 is 64 equals, and now I'm just going to rewrite x squared plus, and I'll actually do 12 squared and get 144. So what's really nice here is I have an x squared on this side and an x squared on this side. So they're actually going to cancel out, right? If I subtract x squared from both sides, they both go away. So I'm left with 16x plus 64 equals 144. So I'm going to get rid of the 64. I'm going to subtract 64 from both sides. So I get 16x equals 80. Divide both sides by 16. I get x is 5. And there's my answer. Pause and try this one, and when you come back, check your answer. All right, we should have put an x there and made this entire side x plus 2 or 2 plus x. And if we did all our work right, we would have gotten x is 3. All right, the next thing I'm going to look at, I kind of call this the ice cream cone theorem. So if we turn this, it would look like an ice cream cone, right? We have our scoop of ice cream and we have the cone. And if you imagine, if you're holding up a cone, if one side of the cone was significantly shorter than the other, your ice cream is going to fall out. So both sides of the cone have to be the same. And that's what this is saying. If I have two different segments tangent to the circle, then they are congruent to each other. So here we have a little ice cream cone. Both sides of the cone have to be congruent to each other. So I know that 2x minus 5 is equal to x plus 15. And if all I'm finding is x, I can just set them equal and solve. So I'm going to subtract x. I'm going to add 5. And that's it. We get x is 20, and we're done. So you're going to try the next one. Pause. When you're ready, come back and check it. All right, so for this, x should equal 3. The last kind of thing we're going to talk about is a circumscribed polygon. So it's considered a circumscribed polygon if every side of the polygon is tangent to the circle. So every single side of our shape has to touch the circle exactly once. So in this picture, we have a graphic designer is giving directions to create a larger version of the triangular logo shown. They're telling us triangle ABC is circumscribed about circle G, which means segment AC touches the circle just once at point D, segment AB touches the circle just once at point E, and segment BC touches the circle just once at point F. We want to find the perimeter of ABC. So what we really have here is 3 different cones on our single scoop ice cream. Imagine that sundae from Friendly's where that has the 2 different cones attached to it. So every cone is a different size, but the 2 sides of the cone still remain the same. So if this portion is 8, this portion would also be 8. Right? These 2 sides make up one single cone. I have another cone here. So if this part of it was 7, that would make this part of it 7. Now this entire side happened to be 10. We already knew from here over was 7, which would make what here over is left is only 3. And now we have a little itty bitty cone over here. So if this piece was 3, this has to match it, and that's also 3. So we have every single chunk that we know on the whole figure, so we can now find the perimeter of triangle ABC. We could either add up every single individual piece, or sometimes what I do is, since I know there's 2 of every piece, I'll do 2 times the sum of the sets. So we have an 8, we have a 7, and we have a 3. So I'm really going to do 2 times 8 plus 7 plus 3. So that's 2 times 18, or 36 feet. I would have gotten the same answer if I did 8 plus 8 plus 7 plus 7 plus 3 plus 3. So you're going to try this last one, all right? same idea. We have round cookies being placed in a triangular package. We want to find the perimeter of the package, the triangle QRS. So go ahead, pause when you're ready, check your answer. All right, so we've sort of filled in our picture as follows. And if we added them all up, this again happens to be 36, but now we're dealing with centimeters. All right, and that's the lesson.